Hello people, welcome back to my channel. So hope you are enjoying this Python skill series. So far we have covered many different videos in Python, and we have covered some of the basics of Python 3 programming language for doing machine learning, or even for data science, or even for data visualization. So these are the basic concepts which will be useful whenever you go into advanced level of Python. So today, let's start with different data structures. So we have something called as set. So before we begin, we have some pointers to be noted about the set data structure. So first of all, to remember is that there are no duplicates that are stored in a set. So if you keep elements in a repetitive manner, or if they are redundant elements, like in the tuple we saw, like we had this repetition operator, so there it stores duplicate elements, repetitive elements. But in set, you have only single copy of the elements in that data structure. Second is that there is no ordering of the elements, means there is no particular indexing that is possible. So hence there is no subscript, like you cannot access elements of a set like s of 0, s of 1, s of 2, the similar way you did in tuple or list. So that kind of indexing is also not possible. And so the elements that you return from the tuple, or the way you enter and the way you get after the processing, will be different. So that is one thing that you have to keep in mind. So there is some kind of a randomness or random behavior when you deal with the tuple data structure. Then, since there is no subscripting possible, there is no slicing also possible with this. So you cannot use the start, stop, or step kind of thing that we saw in the slicing thing. So that is also not possible. So you need to remember about these things. In fact, all these four. So these are the important things while you do with or deal with the set data structure. Next is that it is mutable. While in tuple we saw that it was not mutable. So always remember that mutability will be referring to the memory address where it will be stored, or what will be the memory reference. So it is mutable. And finally, you can store heterogeneous elements like in all other data structures. That facility is also available in Python 3. So we begin with the first discussion, that is how do you create a set. So I have some cells that is predefined so that it saves our time instead of typing. So you can always import this from the GitHub, from my GitHub, wherever I post this, and then you can do the different experiments that you can do with this. So first we have this creation. So in creation we have these many things that is possible. So first of all, whenever we do the creation of a set, it is realized with the help of this curved or curly parenthesis. So in tuple, where it was a round parenthesis, here it is curly parenthesis. And now I just want to show you that. First, what I'll do is I'll just comment these lines here. And now if I run this, and if you expect that this data type would be set, no, it's not. It will be a dictionary. So dictionary will be covering after this. So why this happens is because dictionary also takes this kind of syntax. So unless and until you put elements into it, or you use some kind of constructor, you won't be able to make difference what is a set and what is a dictionary. So whenever you create a set, make sure like you do this way. That is, this is the first way of doing or creating a set. So 10, 20, and 30 are the elements that I put. So whenever you do the initialization as well as definition, you have to put the elements. So this is the static way. And so first, for this you got a dict, then for this you get as set. And there is another way of creating a set, and that is by this. That is, you call the set constructor. So each of this data structure, whether it is string or tuple or list, set, dictionary, each of them have their predefined constructors. So by this also you can do the set creation, so it will also result the set type instead of the dict type. So this was the discussion about the creation. Next I want to just bring in front of you about two different functionalities of this set, and one is discard and the other one is remove. So you might be thinking like both are the same. No, well, it's not same. To some extent it can be said, but there is a slight difference in both these two methods. Let us understand what are those. Okay, so first what I have is I have this, that is s dot discard. So that is a discard method, that is a built-in method discard, and so that is the address of that. So we are not concerned with that. Okay, so I'm referring to this set, that is s here. So I have 10, 20 and 30, and if I say like I want to remove 40, element 40, so since there is no indexing, you don't have to worry about which index it has, so you don't need to count from where left to right or right to left, so that is not possible, so you don't want to do that. So now our discussion is like I want to remove, not remove, instead I want to discard 40 from this. So just for representation or for visualization, if I run this, what happens is like you can see that it didn't throw any error because the set already contained 10, 20 and 30. There was no 40, and so with discard you won't get an error. But this is not the case with your remove function. So if you call for remove, what happens is like you get some error, and that error is called as key error. Means the basic difference between discard and remove is that discard will not throw any error, but remove instead will throw some error if that element is not present. So sometimes when you do certain kind of operations, you have to use discard and remove as per your use case or whatever you're doing. Along with that, you have to do this kind of things. So that's why I have mentioned about this discard and remove. Next, what we have is we have list versus tuple storage. Now what is this? So for this, what I have is, say I have two set, that is A, and in this, as you can see, I have put something in parenthesis, so there is nothing to wonder about. This is completely possible. So since it stores heterogeneous elements, so these two are of uh, integer data type, and this is one tuple and this is another tuple. So now if I want to print this, so is this possible? So this is first way of representation, that is I have this, so I have two integer elements and two tuple elements, and in B what I have is, inside this set I am storing one tuple element, two integer elements and one list elements. Let's see what will be the output of this. So you got one output, that is the first one. You have 5, 9, 1, 2 and 3, 4. And just one more thing to bring into your notice, like we have entered the elements like 1, 2, 3, 4, 5, 9, but you got the output this way. So that was what I mentioned previously, there is no particular ordering of the elements, and because of this random nature, what you input and what you output, you cannot put any indexing or slicing or any subscripting, so that is not possible because of this thing. So back to our discussion. So when we ran A, we got this output, but when we ran B, we got a type error. And if you just see the description, it is of unhashable type list. Means if you are keeping a set of tuples, that is this, and set of tuples along with some integers, it is possible. But inside a set, you cannot put a list. It's not about multiple list, it's that you cannot put list inside a set, so that is one limitation where you can't put that data structure. So with tuple that is possible, with set it is not, with list it is not possible. Next, we move on to that is, we said like there is no ordering, no subscripting, no slicing, no indexing. So for that I have this particular example. So in this I'm using a constructor of the set class or the set data structure, and inside this I'm passing a string that is star link. And now if I want to print this, so it will print this way. So again there is this random nature, so there is no order like how it is printed. So you have KRISANLT in this order. So now if I want to do some kind of, I said like there is no ordering. So say like in A, if I want to access the first element, so it again shows the type error, means set object does not support indexing. Next, if you want to do this slicing, so again it is not subscriptable. So if it is not subscriptable means there is no indexing, there is no slicing, there is no ordering. So this example perfectly explains like what I've written here. So you just have to keep in mind that with set this kind of operations are not possible, whereas with list and tuple or with string this was possible. Next we move on to something called as a pop function. So I've written like it randomly pops the elements. So that is true because now I have considered a set that is S1, and inside this I have tuple. So this is permitted, like from our discussion from above we can keep the tuple elements and there are some string elements. Now if I pop this or pop one element out of this, so it is random, you don't put any index or value, so it does not take that into consideration. Now you get the output as 34. Now why 34? Don't know, no reason for that. So it just happens to be arbitrary. And if say like if I put a value like 56, so it again pops out 34. There is no setting, somehow it is behaving internally in this way, so that's why it is doing this way. Or if I remove this and if I run this, probably see again I'm getting 34. So there is no particular reason why it is always giving out 34. So this is some random nature that is with the set data structure. Next I have something called as the intersection, union, and the superset and subset. So intersection from your Cartesian product, power set, and all these stuffs, where you take the union and intersection of two elements which is common and the complete set, stuffs like that. So from that you have this extension to set, so it is possible. So these kind of operations are exclusive to set data structure. So for that I have considered two sets, that is H and K. This contains four elements and this contains five elements. Now first I will be running this, so let me go here and first this I comment. Yeah, so now since you remember about in set, so far we have discussed like it will not consider any duplicate elements, so redundancies are not accepted in set. So if I run this, the union what you get is 33, 66, 11, 44, and 55. Also there is no sorting of these elements are done. Next if I do the intersection, so this was the result of union first what you can see, and this is the result of intersection. So whatever is common in both these, so in H and K we have 33 common, then we have 11 common, then we have 44, and then we have 55 common. So that is self-explanatory. Then we have something called as to check, that is whether one set is a subset of another or one is a superset of another subset. So now here it returns true because we are checking like whether H is a subset of K. Yeah, because K has higher number of elements and so it can be described, or H, H can be described with the help of K, and so it is a subset of K. And then we have the opposite of that, that is superset. It will also return true, and if I just reverse this, just we are getting true in both the cases. So we have like this, false. So these were some of the operations and some of the methods that are possible in the set data structure. Now what we'll do is we have a small program, that is, now this program is to create two different sets. Now since we know like how we can create sets, so this example says like you have to create two different sets. Now that corresponds to two different dices. Now dice is nothing but your cube where you used to play your snakes and ladders and things like that. So that is the dice, and the dice values are from 1 to 6. That is the faces which you get. So when you throw a dice, you get any of these value one at a time, which is facing towards you. So you get any of this value. So that is the domain knowledge that you get. And then what our requirement is, like you have to create a Python script, and this should produce sample space to get the sum of the dice values when rolled is n. Now this means like you when you throw two different dices, what you get is probably they'll land at two different numbers, or sometimes they will be the same number. So in the least case or in the worst case, you get like 1 1. So the sum of those two will be 2. So similarly you have 1 2 1 3 1 4 1 5 1 6, like 2 1 2 2 2 3 2 4 2 5 2 6. So similarly you have to put the dice or take the input from the user, and then you have to sum of, like put any number like which is sum, and it will return the resultant of those two, like with on what combination this particular number is. So I have already this program written. So I would suggest, like if you would like to give a try to this program, you are free to do it. Just pause this video and just take a time to do it. Okay, so if you are not able to do it, no problem, but we can solve this. So that's very simple. Just a bunch of if else statements are there, and we have done some typecasting. So let us see that. Yeah. So this is our program. So first what we take is, we know like what the eval function does. So when we enter the elements as comma separated, so it will take the input from the user and it will evaluate what type of elements it is. Probably in this case it should be integer. So then it will do the casting, or it will consider all those input stream from the user as set, and it will put into X. Next we print this. So it will be our first dice. So X contains our elements for the first dice. So that is the input for the dice one. Next, in the similar way, we take another variable, that is y, which contains the second set of elements for dice 2. So that is simple. Next, it says like you have a small node that is n is user input. So user is free to input the value for n. So user will input the value for n, and just remember like whenever in dice, the sum of the two faces, the lower bound is always 2. Like whenever you throw two dices, in the rarest of the rarest case you get like 1 and 1, so the sum of those will be 2. And in the uh, highest case, or the larger bound, will be 6 and 6, so that will be 12. So our range is limited to 2 and 12. So in between, any values you can put. Any range outside this or less than or below will not be accepted. So that is the main logic for this. So for that we have a bunch of if else statements. So if you have any other logic that you have thought of by using range function or any other technique, you are free to implement. So I have done this using if else statements. bunch of elif. So I have a elif ladder. So for all the combinations what I have is, so if my n, that is entered value of n, is 2, I will print as 1 1. So this is the only combination that is possible out of the two dice. Next, if I have n is equal to 3, I will print 1 2 2 1. So this is the resultant of 3. Next, if it is 4, then I have these many combinations. If it is 5, I have these many combinations. For 6, I have like this. For 7, it is like this. 8, it is like this. And 9, 10. So you can see that there is a tree that is growing this way. And then at some point of time, it is just decreasing. So this is somewhat a symmetric kind of activity that you are doing. And then what I have is, finally, if you input any number, that is if you by chance or by mistake input n is equal to 13, then it will say like, this is the combination that is not possible, so please enter a value between 2 and 12. So that is simple. We'll just run this code to make sure like everything is perfectly working. So enter the first set of elements by comma separated. So I have 1 2 2 4 6 and 5. So this is the resultant of one particular dice that I'm getting. Next, this is asking for the second set of elements. So I get 2 2 3 5 and 1. Now it is asking for any value of n, say in between of these values from 2 to 12, say I want uh, like 5. Is it possible? So it will give you or generate you these many combinations, which is the resultant of 5. Or like if you add 2 and 3 you get 5, 3 and 2 you get 5, 4 and 1 you get 5, 1 and 4 you get 5. So that is basically this control statement that is executed. So you can try with different combinations, and you can also think over this modification. So if you are free to do the modification, like if you have anything else, like if you are thought of like using the range function, you're free to do it. Or you can, if you want to minimize the lines of code, you can do it. So do different kinds of experiments so that you get a better hold of these stuffs. So well, that was all regarding the set data structure in Python. So hope you guys enjoyed this video. If you found you got educated about this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.